So this lesson is going to take what we did the other day with if lines are parallel, then alternate interior angles are congruent. If lines are parallel, then corresponding angles are congruent. So let me give you some examples, right? If lines are parallel, then corresponding angles are congruent. If lines are parallel, then alternate interior angles are congruent. If lines are parallel, then alternate exterior angles are congruent. And then lastly was if lines are parallel, then same side interior angles that look like that are supplementary. Same side interior are supplementary. They equal 180 degrees. So those are the four choices that we talked about the other day. And then we also know, remember, we also know vertical angles are congruent and linear pairs equal 180. Okay, so those are two other things that we know, but those don't have to do with parallel lines. So we're going to just do the same thing that we talked about the other day, but we're going to do it with this, with algebra. So if I tell you that M is parallel to N, and these are my two angles, so I have this angle and this angle. So you have to look and you say, okay, those two angles, they're interior, they're on alternating sides, so they're alternate interior angles, which means that since the M is parallel to N, that they are congruent to each other. And so you would set up the problem, 5x minus 8 is equal to 3x plus 6. And what I want to find is, what is the value of x that makes those two angles equal to each other? That's what we're looking for. So we'll do the algebra. I would subtract 3x from both sides. I always move my small x first. Then I have 2x minus 8 equals 6. I need to get the x by itself, so I got to keep moving things. So I'm going to add 8 to both sides. So now I have 2x is equal to 14. If I divide both sides by 2, I get that x is equal to 7. And since it only asked me to solve for x, I can stop there. However, if I did want to know how big the angle was, then I could go in and I could say 3 times 7 plus 6, and I could substitute 21 plus 6 is 27. So those angles are both 27 degrees. If I could do a double check, 5 times 7 minus 8 is also 27, and so it checks out. But that's what we wanted to happen, is we wanted them to be equal to each other. So if I look at this next one, again, I have this angle here, and I have this angle here. Notice they form that F. It's upside down, but it's still an F. So since those lines are parallel, these angles are corresponding angles, and since those lines are parallel, those corresponding angles are congruent. So I know that 12x minus 35 is equal to 8x plus 5. So we need to solve that equation. So I'm going to move the 8x first because it's smaller. So that gives me 4x minus 35 equals 5. And I add 35 to both sides to get 4x by itself. So 4x is equal to 40, or x is equal to 10. And again, if I wanted to, I could go back in and plug it in. 8 times 10 plus 5 means that that angle is 85. And I could do 12 times 10 minus 35, and I would get that that angle is 85 also. So with this one, look at your angle. Here's your angle, and here's your 4x degrees angle. Notice that you got your two lines with your transversal. Those two angles are same side. interior angles, which means that they are supplementary. That means that 6x, however big it is, plus 4x, however big it is, have to equal to 180 degrees. Now, you've got your equation set up. All you have to do is clean it up. So 6x plus 4x is 10x. That's 180. If I divide both sides by 10, I get that x is equal to 18. And from there, I could go in and I could plug in my numbers just so you can see it. 4 times 18, so you can see it works. 4 times 18 is 72. 6 times 18, because now we know what x is. 6 times 18 is 108. And if you notice, 108 plus 72 is equal to 180. Now in number 4, I have 2 sets of parallel lines, and so I want to look. Now, you might just notice this and be willing to just make some observations and look at them. And so I look, okay, the first thing I see is these 2 angles right here. But here's the problem. I have 3x and 4y. The problem is I have 2 variables. So that's kind of ugly. I don't want to deal with that. So I'm going to see if there's anything else that I can do. Well, since S is parallel to T, I can also take this angle and this angle. Because those 2 lines are parallel, I know those are alternate exterior angles. So that means that 3x has to equal 96 minus 3x. So I went from this angle down here, I traveled down that transversal to that angle, and S was parallel to T, and so I was able to do that because I want to go from one parallel line to another. So from there, I need to solve it. So I'm going to move this 3x over here to give me 6x is equal to 96. So 96 divided by 6 is 16. So x is equal to 16. I just divided both sides by 6. So if x is equal to 16, I still have to find y. Don't forget, I still have to find y. So I can do 3 times 16, and I get 48, which means this angle is 48. So now you have a couple of ways you can look at this next part. You can either recognize that those 2 angles, these 2 angles here, are same side interior angles, and so they're supplementary. So 4y plus 48 is equal to 180. Or you can go ahead and know that if you recognize that, you could also say, well, then this angle has to be 132 for those 2 angles to be supplementary. So what does 4y have to be to equal 132? Well, notice if you take 180 minus 48, you would have done that for either way that you set up the problem. So 132 divided by 4, you get y is equal to, divided by 4 on both sides, you get that y is equal to 33. And since I asked for x and y, I had to actually go in and solve for y. I couldn't just leave it at 132 degrees. So we use all of the same things that we used the other day with just regular numbers, and now we apply them with setting up equations with algebra, where corresponding angles, alternate interior angles, and alternate exterior angles are all congruent when the lines are parallel. And same side interior angles are supplementary when the lines are parallel. Those rules only apply when the lines